Hi, hello, namaskara. Once again, welcome back to Diksha Karnataka channel. So, as you can see on the screen, Abhyas KCET 2024 mock test series have begun, and we have put the WhatsApp channel link in our description where the question paper will be available. So, please go check out the question paper soon. Try to attempt it. And today we are going to do an in-depth analysis and solution discussion of the paper. So, this once again, as we usually do in our videos, will have two parts. So first part will contain questions 1 to 30 of the physics portion. Alright, so this series is mainly for those people who are very serious and preparing towards the KCET examination, aspiring to score very good scores. So please be with us, subscribe to our channel for more such videos. So we are creating analysis videos for previous year question paper mock tests and whole lot of interesting content. So please subscribe, and if you like the channel, please do like it. All right, fine. So let us move ahead to the question paper discussion very quickly. So let's see our first question. Okay, first question is: the potential energy of a satellite having mass m and rotating at a height of 6 into 10 to the power 6 meters. Okay, so there are several things that you have to keep here in mind. So first of all, it is at a height of 6.4 into 10 to the power 6 meters. Now this is actually the radius of Earth. Alright, so if you know the quantity value, if you have memorized it, see, when we do a lot of problems, the certain numbers sting to our mind. So actually the radius of the Earth 6.4 10 to the power 6 meters. So it is that height, and they are asking what is the potential energy. So all of you know what is the potential energy at any height, at a particular height. It is GMM divided by RE plus H, and here in this case it is, and there is a negative sign as well. Okay, GMM divided by RE, and H is RE as well. So we have 2 RE, RE plus H and negative. So there is 1 by 2 extra coming here. So that can be taken as 0.5 minus 0.5 into the remaining whatever it is. That is GMM by RE, or you can also, this is also equal to MGRE. All right. So GMM by RE can also be written as GMM divided by RE can be written as GMG into RE. All right. They are equivalent, and therefore this gives our first answer, that is option C. Okay, so this question can be categorized as not so easy, not so difficult, also somewhere in the middle. I would try to put it towards the easier side because it's just the formula. If you know the formula and if you identify H as 6.4, that is what I might put it towards, little bit towards the medium part. So if you remember this value, then it will be easier. All right, so to categorize and to know what is the correct representation of the answer itself. All right, so C is the correct answer. Fine. So let us look at the next question. Next question is, okay, which of the following statement is correct regarding Poisson's ratio? Now I would like to bring in a clarity. Poisson's ratio is actually not involved in the KCET 2024 syllabus because it has been taken off. KCET 2024 syllabus is on par with the PUC syllabus. So Poisson's ratio is not actually included, but since the question has come and it's little bit general while looking at the options. So the options are, it's the ratio of longitudinal strain to lateral strain, and value is independent of nature of the material. It's a unitless dimensional quantity, and practical value of. So the correct answer over here is actually option C. It is a unitless and dimensionless quantity. So we are taking a ratio of two stresses. Okay, so that is lateral and longitudinal in a different way. So option A is not correct. The correct answer is option C. So since this is not a part of the syllabus, we needn't put a lot of emphasis on this. Let's move on to the next question. The next question is, a wheel of car is rotating at a rate of 1200 revolutions per minute. On pressing the accelerator for 10 seconds, it starts rotating at 4500 revolution per minute. What is the angular acceleration? Now this is very simple because they have given a lot of things in the question. So they have given the initial, okay. So initial rotation, that is omega 1, is actually 2 pi into frequency, that is 1200 revolutions per minute. So per second it is 1200 by 60. Okay, so this is radian per second. And similarly we can have the second Now after accelerating, it becomes 4500. So here also we can apply the same thing. All right, radian per second, and ultimately so the time taken is 10 seconds. What is the angular acceleration? So angular acceleration, first of all, if you want in radians, you can do the direct one. So we have acceleration is equal to omega 2 minus omega 1 by t. So we have 2 pi is common both the places. So you have 4500 minus 1200, because common divisor it is 60 whole divided by 10. Now this will fetch you an answer in radians per second, but according to our options, 30 and 40 is not possible. So basically we have to try with the 180 and 1980. So in that case, when if you have to convert this into degrees, so what do you do? The same thing, 2 pi into, so it is 3300, okay, divided by 60 whole divided by 10 into, how do you convert this radians per second into this thing? So we have 360, or you can do 180, anything, 180 by pi, or it is 360 by 2 pi degrees. And finally you will get the answer as option D, 1980 degrees per second square. All right, so I am not going with the detailed calculation, because I have given you the formula and I have given the proper substitution. So you can verify once again the calculation, and if at all you have any difficulty in understanding this, or in you have any contradiction with the answer you get, definitely I would like you to put it in the comment section, okay, so that we will know, we can have a discussion there itself. Fine. So this is the answer for this question. Let us look at next question, or do we have something else? Yes. So once again, I would like to remind you about the Lakshya CET crash course that we have conducting. In 28 days, we will prepare you for the KCET 2024. That is using our Lakshya crash course. So for any details, once again, please be in touch with our channel. So don't forget to subscribe it. So more and more content regarding this we'll let you know, and also don't forget to join the WhatsApp channel which is there in the description box. Next, let us look at the next question further. So we have the cylindrical tube of spray pump has a cross section of 8 centimeter square, one end of which has 40 fine holes, each of area 10 to the power minus 8 meter square. If the liquid flows inside the tube with a speed of 0.15 meters per minute, the speed with which the liquid ejected the hole is. Now what you have to keep in mind is, see, this is basically a question based on continuity principle. Okay, it's very simple. So we have two ends. First we have the spray pump. Okay, spray pump. So when you talk about spray pump, so the continuity principle says that the volume of the rate of flow, okay, rate of flow, that is area into velocity, it's same both the sides. Okay, spray pump A1 V1 is equal to the holes, okay, the holes, that is A2 V2. So I'll write it separately. So spray pump has an area of 8 centimeter square, 8 into 10 to the power minus 4, because when you convert it to meter square, just for the standard this thing, and the liquid flows through each inside the tube with a speed of 0.5. So this is 0.15 and it is per minute. So let's convert that into seconds. Okay, now this is equal to the area of the holes. There are 40 holes, so 40 into each having an area 10 to the power minus 8 into V2. All right, so we have to find V2. Rest everything is given, so we can put it here, and ultimately you will get the answer. If you just substitute and you can do the necessary calculations, ultimately you will end up with the answer as V2 is equal to 5 meter per second. Okay, 5 meter per second, which is the option B. All right, once again you can do the just cross multiplication, isolate V2, and with further calculations you will reach the answer as 5 meter per second. All right, so this is also a very simple question. I would definitely categorize this as an easy question. So you just have to keep in mind the principle of continuity and apply the values, and you will get the answer correctly. All right, fine. So let's look at the next question. Next question is a very simple question, very straightforward theory based question. a beaker is completely filled with water at 4 degrees Celsius. It will overflow if it is heated above 4, cooled below 4, both heated and cooled above and below 4 respectively, none of this. Now, what is the speciality of 4 degrees Celsius? So, the density of water is maximum at 4 degrees Celsius. That is the speciality of 4 degrees Celsius. Density of water is maximum at 4 degrees Celsius. That means above 4 degrees Celsius, below 4 degrees Celsius, the density is less. Density of water is less than what it is at 4 degrees Celsius, both above and below. Okay, so you heat it above 4 degrees Celsius, cool it below 4 degrees Celsius, the density is going to reduce. Now, mass is going to be same because conservation of matter, mass is going to be same. Density is equal to mass by volume, right? So when the density is decreasing, that means that the volume is increasing, okay, which implies if the density decreases, that means that volume increases. So either you heat it above 4 degrees Celsius or cool it below 4 degrees Celsius, the volume is going to increase. Therefore, it is going to overflow both heated above 4 degrees Celsius and cooled below 4 degrees Celsius. Once again, very simple, straightforward, concept-based question. You just need to know the specialty of 4 degrees Celsius for water. So water has highest density at 4 degrees Celsius. Therefore, when you heat above or below, density decreases, volume increases. Therefore, it will. All right, very simple question. Let us look at the next question. Once again, it's a theory-based question. So this question is the graph is plotted with PV by T on y-axis and mass of the gas along the x-axis for different gases. The graph is, now first of all understand, we have a graph in which you have PV by T as the y-axis and mass, given mass as the x-axis. Now you have to understand what is the relation between PV by T and mass so that we understand how the graph's nature is going to be. So PV by T according to ideal gas equation, it is equal to NR, number of moles into R is the gas constant, right? And number of moles is simply calculated by given mass by molar mass into R. Now here, let's isolate given mass because that is our x-axis, and R by M, molar mass. So for a given mass, this is a constant, gas constant by molar mass. For any given gas, particular gas, the molar mass is fixed. Ideal, of course, R, the universal gas constant, is constant. So PV by T is directly proportional to R. That is the relation. PV by T is directly proportional to our mass. And in this equation, there is no x intercept as well. There is no constant, so there is no x intercept. Therefore, it is a straight line which is passing through the origin. Yes. So the correct answer over is straight line parallel to x-axis, no, passing through the origin with a slope constant. Yes. The correct answer is option B. Alright. Sorry, it's not the same for all the gases. Of course, it depends upon the, option C. Okay, because it, for different gases, the slope will be different because molar mass is going to be different. So the slope is going to be different. So different values for different gas, constant value for all the gases not valid because we have to consider the molar mass as well. Alright, so the correct answer over here is option C. Alright, once again, straightforward question. You just need to know this particular understanding of ideal gases, you will directly get it. Alright, very nice. Now let's see the next question, shall we? Once again, a very straightforward question. A perfect gas contained in a cylinder is kept in vacuum. If the cylinder suddenly bursts, then the temperature of the gas is, yes. This I would place somewhere between easy and medium. Why? Because, so you have to understand what happens. There are multiple clues given in the question. A perfect gas, okay, ideal gas, contained in a cylinder, kept in vacuum. It is in vacuum already. Okay, cylinder suddenly bursts. Okay, so there are several things you have to understand from the question. That's why it's not completely easy question, even though it's a theoretical question. You have to think. First of all, cylinder blast, that means it's a free expansion. Okay, it's a free expansion. Cylinder blast is free expansion. It is kept in vacuum. Okay, so pretty much we understand it's a closed and isolated system. Closed and isolated system. First of all, there is no exchange of heat. Okay, there is no exchange of heat. Heat is not given or taken. And since it is free expansion means that there is no work done by the gas or on the gas. It's a free expansion, right? So work done is 0, there is no work done, and here there is no heat transfer. That means according to the first law of thermodynamics, what happens is that delta Q is equal to delta W plus delta U. Now this all condition implies that delta U is also 0, delta Q is 0, delta W, that means delta U is also 0. That means that the temperature remains constant. There is no change in the internal energy, therefore temperature remains constant. So why is this not exactly an easy question? Why? Because multiple clues are there in the question. You have to identify them and then address them accordingly. So free expansion, work done is 0. It's kept in vacuum, so there is possibly no chance of heat exchange. So heat exchange is null and work done is null. So basically internal energy is 0, therefore temperature remains constant. Only if internal energy changes, temperature will change. Alright, yes. So yes, this is somewhat mediocre difficulty question. Look at the next question. So if the length of a simple pendulum is increased by 2%, then the time period, yes. Now this is a very important question. There is a lot of chance that similar type of question, not exactly similar type, like one quantity is changing, rate of change in percentage, and how is that affecting another quantity, rate of change. So first of all, let's see how the time period and the length of a pendulum is related. Okay, time period is actually proportional to, okay, some constant into, one second. Now because we only need the proportionality, we don't need the entire equation. It is proportional to root L by G. Alright, so all of you know this, time period is proportional to root L, directly proportional to square root of L, inversely proportional to square root of G. Now G is not an issue because we are considering an case on earth, so G remains constant, let's assume. So the time period is directly proportional to root of L. Now this gives us the next step, which is the most important step, the rate of change. Okay, so how is T, change in T affecting? So we can use it as the error. Okay, so this is kind of the relative error kind of a technique that we are applying. So this power gets multiplied. Okay, so this is a very important result, how you can find out the rate of change of one quantity affecting the rate of change of the other quantity. Alright, so this can be applied throughout multiple concepts, multiple formulae. Okay, so now you can get the answer very simply. So rate of change of time period is 2%. Okay, sorry, length is 2%, my mistake, one second. So yes, so delta T by T is equal to 1 by 2 into delta L by L is 2%. This is delta L by L, right? So when you substitute this into 2%, ultimately what you will get the answer as, it is 1%. And it's a positive value, so it is increasing. If it was a negative value, it decreases. It's a positive value. They both are directly proportional, right? So if length increases, that implies that time period also increases. So it is increasing by 1%. The correct answer is option C. Once again, this is somewhere between easy and difficult. So if you know this particular method of converting, if you get the proportionality relation, from there you get it to the what you say, the error kind of like rate of change of a particular quantity, then easily you can arrive at this relation. If you get this relation, then the next step is very simple. Alright, so please practice this kind of question. These are very important kind of problems, this kind of problem where one quantity change affects the other quantity. Alright, so next, 5.5 meter long string has a mass of 0.035 kg. If the tension in the string is 77 Newton, the speed of wave in the string is, once again, this is a very simple question, very direct question. Velocity of waves in transverse waves in a string. So it is easily given by T by mu. Mu is the linear mass density of the string, M by L. So substitute all the values, L will go up. Okay, substitute all the values. So 77 into L value is 5.5 divided by mass is 0.035. So just calculate, you can do the calculation yourself, right? So you can cross check, and ultimately the answer that you would be arriving at is 110 meter per second. The correct answer is option A, 110 meter per second. Very simple question, students. Direct formula, substitute the values and calculate, and you will get the answer as 110 meter per second. All right, fine. So let us look at the next question, shall we? Yes. So the one metallic sphere A is given positive charge, whereas the other identical metallic sphere B of exactly same mass of A is given equal amount of negative charge. Then, now this is a slightly tricky question. It seems very easy, and slightly tricky. Why? Because given positive charge, given negative charge. Now according to quantization, just think. So quantization of charges lets us know that if a body is having some net charge, that is coming from the electrons. So the electrons are the one which is causing them to have a charge, because they are the ones which is available at the outermost extent of the atom. Protons are way deep inside the nucleus. Okay, so most possible way of giving a charge or getting charge in a body is through manipulation of electrons. Okay, so suppose if a body is given positive charge, this means that electrons are removed. Okay, given positive charge in the sense electrons are removed, and it is given negative charge means actually literally electrons are given. Okay, electrons are added. Okay, electrons are added. Electrons added. So how does an object become positive? Electrons are removed. How does they become negative? How do they become negative? Electrons are added. Okay, so now think logically. Metallic sphere A has electrons removed. Electrons are removed, so it is positively charged. Sphere B has electrons added. So basically, even though minute quantity, I understand, who will have a greater mass? Even though it's a minute change, who will have a greater mass? Yes, the mass of B will increase. Okay, mass of B will increase because electrons are given. Electrons are added into the body, so mass of B will be increased. All right, very simple logical question. If you think straight, you will get it definitely. All right, so you have to think. That's why it's not easy question, it's slightly tricky question. Okay, you have to think. So there are hidden clues in the question you have to find. Next, if the electric field is given by 5I cap plus 4j cap plus 9 cap, let me just write the vector form. Okay, 5I cap plus 4j cap plus 9k cap. Alright, and the electric flux is through a surface of area 20 units. Okay, so the area is 20, magnitude is 20, lying in the YZ plane. Now YZ plane. So for flux, maximum flux, assume maximum flux, we need an area, means electric field passing through a particular area perpendicularly. We need electric flux, electric field passing through an area perpendicularly. So what is the direction perpendicular to YZ plane? Obviously it is the X direction. Okay, so area vector can be taken as, for calculating flux we need the vector. Area vector can be taken as, of course, the magnitude is 20 and it is along the X axis. So now how do you get the flux? It is simply E dot A. So we can find the dot product of 5I plus 4j plus 9k dot 20I. So you know the dot product, only the similar unit terms will get matched. So we have 100 units of flux, option A. Once again, it's a very simple question, very simple. Yes, not even mediocre type of difficulty. It is very simple. So you just need to take the vector form of A, which you will have a proper idea once if you practice sufficient number of questions. YZ plane, any plane if they give, the area vector is perpendicular when you have to find the maximum. Unless they have given in the question it is at a particular angle or something. Now it's not given, so we assume we need the maximum flux. It is perpendicular to this area, so it is 20 I cap. Okay, YZ plane means I cap. If it was XZ, it is J cap. So depending on the planes. Okay, fine. So this is a very simple question. Let's look at the next question, shall we? Next question is, yes, 3 concentric metal shells A, B and C of respective radii A, B and C, where A is smaller than B, smaller than C. So it is somewhat like this. So we have this A, we have another one, this is B, and we have the largest one, and this is C. Alright, so 3 concentric spherical shells of 3 different radii. Now they are having a little bit of charge density as well. negative sigma and positive sigma. Okay, so different charge densities, positive, negative, positive, fine. So now how do you find the potential at B? How do you find potential at B? Definitely normal potential of multiple cells. How do you find out potential at A due to A plus potential due to B plus potential due to C, right? So how do you write them? How do you expand them? So we have K into Q at A divided by RB, because we want to find at B, you take that particular radius, K into QB into RB plus the last one is the outermost shell, so we will take QC divided by RC, because it's outside we have to take that particular one. Now just see all of this, take the common things outside. K is of course 1 by 4 pi epsilon naught, okay, and the charge at each place is sigma into that particular area A square, and this is B, RB is B plus sigma, okay, sigma 4 pi B square by B. Once again it's negative because it's a negative sign, it's a negative charge density, so we have negative, plus the ultimate one is 4 sigma 4 pi C square into sigma divided by C. Okay, so now cancel all the common terms, that is 4 pi will get cancelled everywhere, okay, 4 pi will cancel everywhere, sigma will come common outside, so we have sigma by epsilon naught, B is common, A square minus B square by B plus C, okay, because C and C square will get cancelled once again, C. So the correct answer over here is option B, okay, which is matching to our answer. So this, yes, this is not an easy question, students. I would place it somewhere between mediocre and difficult, okay, it's not mediocre entirely, means it should be, ideally it should be mediocre, but if you don't know the particular conceptualization of potential for shells, spherical shells, that to multiple spherical shells, it is going to be difficult. So you need to know like which shell will have what, like we have multiple shells and exactly the middle shell, which and all potential will it include and how will it include. So everything that is within the shell will have that same distance value, RB. If we have even smaller one, we will have to include the same distance and that particular charge, like we have to include charge of A, but of course distance of B, charge of B, distance of B, and anything outside that particular mentioned shell, we have to take that particular charge and that particular distance. Inside the common distance and respective charges, outside particular charge, particular distance, okay. So this is how you conceptualize, and of course after this it's not very difficult, charge is the area density multiplied by area, so you will get the ultimate this answer, alright. So this once again please mark it as an important question. These kind of questions can be asked, application of Gauss law and charge density, charge distribution, area linear and volume charge distribution, so very important, please focus on such questions, alright. Equal charges Q are placed at the four corners A, B, C, D of a square of length A. The magnitude of the force on the charge at B will be, so very simple, four corners of a square, now here the vector knowledge of vector is very crucial, A, B and C and D. So now everywhere it's positive charge Q, everywhere plus Q, and we have plus Q, we have plus Q, we have plus Q. Now what is the total net force on B? So all the remaining charges will exert a force. How? Let's see the direction. This is force due to D, FD. This is the force due to A, okay, the force due to A. Now this will be the direction of force due to C, alright. So there are three forces. Now we have to find the net force. So net force, once again these two perpendicular forces will have a net force along this particular direction, net force along this particular direction once again, okay. this particular direction. One second, let me take a brighter, yes, this particular direction, and this is the combination of FD and FA, FDA or FAD, the combination of FD and FA, they are perpendicular, they will have a net. So the total net, ultimate net force will be, total force will be FC plus the combination of FDA or FAD. Alright. Now what is FAD? It is the combination of two perpendicular similar forces. Why similar? Same charge, same distance. The distance is A. Okay. Yes. Length is A everywhere. So the same distance and same charge. So FD and FA will be normal, K into Q square by A square. Okay. So I can put it as something like this. So AD will be the resultant of two equal forces, that is FAD will be resultant of two perpendicular forces, which is given as root 2 into FA or FD, because they both are same, you can write anything. So root 2 into FA or FD. So what is either of the value? 1 by 4 pi epsilon naught, K value 1 by 4 pi epsilon naught Q square divided by A square. Okay, so this is the FAD. Okay, this is the FAD, root 2 into either of the forces FA or FD, because resultant is that side. Okay, so let me write in the same this thing, because that will be better, you will have a better understanding. Okay, so FD, let me write in this particular color, FAD is given as root 2 times FA or root 2 times FD, because they both are same, it doesn't matter. Okay, you can catch it anyway. So ultimately the final answer is going to be now FC. Now what is this distance? If this is A, this distance is root 2A diagonal. So you can apply the normal formula, that is 1 by 4 pi epsilon naught, once again Q square by area, this distance square is root 2 into A square is 2A square. So 2 you can take common outside. So ultimately you have 1 by 2 plus root 2 into Q square common, 4 pi epsilon naught A square. This is common. So this you can take common outside. Only thing is 1 by 2 plus root 2, which is essentially option C. Take the LCM, you will have 1 plus 2 root 2 by 2 Q square by 4 epsilon. Yes, so slightly lengthy, but actually it's a very easy question conceptually. So somewhere between easy and difficult. If you are not very strong with your vectors, then definitely it's going to be slightly tough for you. If you know the concepts of vectors, how when two vectors are perpendicular, how does the resultant come? If you know that, you can easily calculate. Alright, fine. So this is not a very difficult question, not very easy also, somewhat in middle. Alright, fine. Let's look at the next question. Yes, 134. 2 points P and Q are maintained at potentials of 10 volt and minus 4 volt separately. Okay, so we have P and we have Q. So this is 10 volt and this is minus 4 volt. So the work done in moving 100 electrons from P to Q, okay, not exactly and Q, it is P to Q, from P to Q. So what is the work done? Now work done, all of you know, work done is equal to charge into potential difference. Okay, so P to Q, VQP. Okay, VQP from P to Q. So what is the, now charge, all of you know, 100 electrons. So it is negative charge, 100 into 1.6 into 10 to the power minus 19. When you are doing potential question, the sign is very, very important. And the difference in this Q and P, minus 4 minus 10. Okay, minus 4 is the potential at Q, minus P. So that is the potential difference. Okay. So the final answer, you can multiply, you can do the calculation yourself, is minus 14 into this. You will get ultimately the answer minus minus is plus. Yes, 2.24 into 10 to the power minus 16 joules. The correct answer is option C. 2.24 into 10 to the power minus 16. So this is the correct answer. Alright, very simple concept, between 2 points how much work is done. So you need to find the potential difference and multiply by charge, you will get the work done. Very simple, very, very simple direct problem. Right. Yes, now let's look at the next question. A parallel plate capacitor with air between the plate has capacitance 9 picofarad. The separation between the plates is D. The space between the plates is now filled with two dielectrics. One of the dielectric has dielectric constant K1. Okay, so we have like this, and let's choose a different color to highlight them. And we have a partition. Here the K value K1 is equal to 3. Distance is D by 3. Okay, this is D by 3. And the other one is K2, which is 6, and it is 2D by 3. Okay, remaining. Fine. So now first of all, when you have two dielectrics of this kind of a combination, it's basically a series combination, right? So two dielectrics will act as a capacitance on their own, and they are connected one after another. So they are like in series. So in series, what do you do? The normal capacitance, total capacitance is given by 1 by C1 plus 1 by C2. Now here, if you have to write the individual formula, you can write it as 1 by C1, right? 1 by C1 is 1 by, that D1 will go up, divided by K1 epsilon naught A. Okay, this is 1 by C1, reciprocal of C1, plus C2 similarly D2 divided by K2 epsilon naught A. Now ultimately you want the C equivalent, total C equivalent is equal to, so you will have just cross multiply, and we can take the common terms as like this. Yes, of course, K1 K2 epsilon naught A divided by, so we will have D1 plus D2, K1 D2 plus K2 D1. All right. Yes. So we will have all of this, right? We will have all of this, and now you just have to substitute. Okay. So K1 D1 K2 D2, all these values are known. Now what is epsilon naught A? Epsilon naught A is actually epsilon naught A divided by total D. Okay, the total distance D. Total distance D is equal to already 9 picofarad, sorry, 9 picofarad, which is already given. Epsilon naught A by D is equal to 9 picofarad. So now what do we do is, epsilon naught can be written as 9D. Okay, 9D. So substitute in place of epsilon naught 9D, and rest all of them can be substituted as it is. You can do the substitution yourself. So we have 3 into 6 into 9 into D divided by 3 into 2D by 3. Okay, K1 D2 plus K2 D1, 6 into D by 3. Okay. So sorry for the space crunch. So you can write it as it is. You can substitute all the values, and when you calculate, ultimately you will get the answer as 40.5 picofarad. D will get cancelled, both the places D will get cancelled, top and bottom, and C equivalent final capacitance will be 40.5 picofarad. So you can please try this. You can take all of this. If at all you are having any confusion or any hiccups, please let me know in the comment section. Okay, so this is slightly lengthy because you have to just formulate diagrammatically and put into the formulas and just get it. So if you are so well versed and practiced, maybe this will be slightly easier for you, otherwise it's going to be tough. Okay, depending on the kind of amount of work that you have to do it for it. Okay, so effort wise, yes, it is slightly on the difficult side, but conceptually, if you are clear with the concepts, you can try to do it. Yes, you have to get it done within that particular frame of time. Like, you have every question has 80 seconds, you have to get it done by that time. All right. So in that case, slightly difficult, but yes, it's a very important question, very interesting question. Okay. So such questions, just please take it seriously, because these challenge you, these lets you know your level. So how far you have to focus in this, how far more you have to gain knowledge in order to attempt to the CET level. All right. So 135, let's go to the 136 question. So next question is, an oil drop of radius r and density rho is held stationary in a vertically upward electric field. If rho naught lesser than rho is the density of the air and E is the charge on the electron, then the drop has, okay, so what does it have? Does it have electrons excess or deficient? Now first of all, you have to understand conceptually what is happening here. You have an oil, okay, you have an oil drop, and there is an electric field in the upward direction. So electric field in the upward direction, and if it is staying as it is, so there is a repulsive force, right? Electric field is in the upward direction. There is another force in the downward direction, that is the of course its own weight. So there is a weight downwards, electric field upwards, and then if it is staying there, it's a balance, okay, two equal opposite forces. So actually the drop is being repelled, that's why it's not falling down, it's just hanging there, just balanced by a downward gravitational force and a repulsive upward electrostatic force. So if the drop has to be maintained, that's a repulsive force, and if it has to be repulsive force, given the direction of electric field, like it always electric field goes from positive to negative, so this drop is having an overall positive charge. The drop is having an overall positive charge. With that itself, we have to eliminate two wrong answers. So this is kind of a technique in the examination. If you exactly don't know what is right away, you will know what is wrong right away, okay, like some things will not be very correct conceptually. So if there is a positive charge, basically electrons are not in excess, so option A and B can be removed, discarded instantly. Why? Because the drop is held, electric field is upwards, so given the direction, nature of the electric field, and if the drop is held, there is a repulsive force, and that's only possible when it is positively charged. So that will give you, first of all, there is no excess electron, there is deficiency in electron. Now the problem is how much is it deficient? So this can be found out by equating both of them in equilibrium conditions. Electrostatic force is number of electrons into the field, this is electrostatic force, this is equated to the gravitational force. How do you find the gravitational force? M into G, we don't know M mass. How do you find that? Using the other given option, that is density. So first of all, mass is volume into density, 4r cube divided by 3, 4 by 3 pi r cube, of course volume, into density. Now density you can't assume just of the oil, you have to take the net density of oil and air, because there is air as well. So that is rho minus rho naught into G. Yes, so this is the equation. Electric field, electric force, Coulomb force equated to the gravitational force. Now you want the number of electrons, right? Just bring the E into E down, N is equal to 4 pi r cube rho minus rho naught into G divided by 3E into E, which is absolutely option C. There is a deficiency of this much amount of electrons, okay. So very simple as in the conceptual flow is important. So first of all, identify whether the electrons are excess or deficient. We know that they are not in excess, they are deficient because it's positively charged. And how much is the number? So you can, using the equilibrium concept, so the electrostatic force is balanced by the gravitational force, or in fact gravitational force is balanced by the electrostatic force. That's why it's stationary in air, and from there you will get the number of electrons. Alright, fine. So this is not a very easy question, not very difficult also, somewhere between. So the difficulty level can be characterized as mediocre. Alright, let's look at the next question. The next question is, okay, it's a graph based question. Which of the following graphs show the variation of electric field E due to a hollow spherical conductor? That is the biggest clue that you can get. Hollow spherical conductor of radius r as the function of distance from the center of the spherical conductor. Okay, so as the distance increase from the center of the spherical conductor, how does the electric field vary for a metallic conductor? We are talking about conductor. Okay, so what happens in a conductor? Inside the conductor, electric field is 0, which is very well known. Which of the graphs gives you a 0 electric field inside, a value less than the radius? It is option A. So option A, electric field inside it is 0, and outside of course it is normal, it is inversely proportional to r square, just like any other shell. Outside it depends, it's an inverse square dependence on the distance. So the correct answer is option A. Okay, it's a very simple question. If you know the property of conducting shell or any conductors, will get you this answer directly. Alright, fine. So let us have a look at the next question, shall we? Next question, yes. In the equation AB is equal to C, A is electric current density. Okay, AB is equal to C, A is the current density, C is the electric field. What is B? Okay, now if you remember the relation between current density and electric field, which is given straightforward in the textbook, you know that J into rho is equal to electric field. So the correct answer is resistivity. Now if you don't remember, suppose if you don't remember the formulas by chance, what you do is you can still try it out using the known formulas. The known things is current density and electric field. So how can you use them? So you can use them like this. So J into something is equal to E. So you can keep that quantity as X is equal to E divided by J. Electric field divided by current density. Now what is electric field? It is V divided by L. Potential difference per unit length, that is electric field, divided by current density is I divided by A. Alright, just rearrange this. V by I is R, L goes down into A. What is R into A by L? We all know it is nothing but rho. So the unknown quantity is nothing but resistivity. So whenever you get such kind of a question, please try to utilize the known quantities, just manipulate them little bit here and there, and you will get the answer, desired answer directly. Or if you know the formula, then it's a easy question. So this question can be characterized both easy as well as medium. So if you have to use this, yes, you have to work out a little bit and you have to derive a lot of things and ultimately get the answer. Okay, but if you remember, it's a very simple, direct, you can directly go to the option A. Fine. All right, let's go to the next one. Okay, 139. If negligibly small current is passed through a wire of length 15 meter and resistance 5 having uniform cross section, then the coefficient of resistivity is. Now this is a very straightforward question. We just saw the formula. The formula is R into A divided by L, resistivity. Resistance is given as 5 and area is 6 into 10 to the power minus 7 divided by length is 5. Okay, so that's all. Sorry, 15 meters is the length, sorry, my mistake. Alright, so you can directly cancel 5, 15, that is 3, 3 and 2. So finally you will get the answer as option B, 2 into 10 to the power minus 7 ohm meter. Alright, very simple, very straightforward question. There is no chance of any doubt over here. Direct formula substitution, get the answer. Alright, yes, next question, let's see. Current of 1 milliampere flows through a copper wire. How many electrons will pass through a given point in each second? This is also very trivial question, very trivial formula. Current charge relation. Current is equal to charge per unit time. So time is given as in each second, so time can be taken as 1 second. Okay, charge is given as quantization. Okay, how much electrons? So you have to take the quantization concept, N into E, where E is 1.6 10 to the power minus 19, right? NE divided by T. So and current is how much? 1 milliampere, 10 to the power minus 3. Now just cross multiply and you will get the N value as ultimately option C, which is 6.25 into 10 to the power 15. Alright, so if you have a lot of the calculations, I am just skipping because I have given you the substitution. You just have to cross multiply, find the desired value. So calculation you can do it on your own. Wherever you find any contradiction or you are doubtful, please let me know in the comment section so that we can just look it up and kind of have a clarification later on. Alright, so the answer given over here is option C, 6.25 and 10 to the power 15. Fine. This once again is a very easy question, very simple question. Let's look at the next question. Yes. Now the number of free electrons per 100 mm, okay, per 100 mm of an ordinary copper wire is 2 into 10 to the power 21. Average drift speed of the electrons is 0.25 millimeter per second. Alright. Now, the formula is very straightforward. This is a very straightforward question. The current is asked with respect to the drift velocity, that is NEAVD. Alright, now the question has a slight, misrepresentation. So per 100 mm, okay, so they have given lengthwise, but length is not what we actually need here. We need the area, okay. So you can take it as, instead of 100 mm, you can take it as per 10 meter square, okay. So instead of per 100 mm, you can take it as 10 meter square. So when you substitute that, okay, so maybe you can use the density quotient as well, but just for your ease, just take it 10 meter square, and then when you substitute the other things as it is, 21 into E is 1.6 into 10 to the power minus 19 into area is 10 into VD is 0.25 mm, right? So it is 10 to the power minus 3. Yes, minus 3. So calculating everything else, just the powers of 10. So 21 and this is minus 19, so you will get 10 to the power 2. 10 into 10 to the power minus 3, 10 to the power minus 2. So all of this will get cancelled, all the 10s will get cancelled, okay, depending on their power. Ultimately you will be left with 2 into 1.6 into 0.25, which is very simply 0.8 ampere. So the correct answer over here is option D, 0.8 ampere. Alright, so this one correction, just please make it, and accordingly you can take the answer. Alright, fine. This also is a very easy problem, direct formula substitution and you get the answer. Fine. Let us look at the next question. Yes, we are able to fairly obtain a large current in a conductor because, now this is something that you have to relate your drift velocity. Drift velocity basically is a very low, like a quantity with a very less magnitude. The magnitude is very small of drift velocity. It's something 10 to the power minus 6 minus 7 range. So it is not very large. First of all, the option A has to be disregarded because it is having fair large, not because the drift velocity is large. The correct answer is option B, because the number density of free electrons is very high. You just saw in the previous question, the number density per unit area or per unit volume, it is like 10 to the power 21, 10 to the power 23. So many free electrons are there. That is huge. Okay. And can compensate for the low values of drift speed. Drift speed is actually low and the very small magnitude of electron charge. So in the previous question we saw I is equal to NEAVD. Okay. So that n value 10 to the power 21, 23, that can compensate for small electron charge, small drift velocity, everything. Okay. So the correct answer is option B. We are able to get fairly large current because the number density of electron is huge. Alright, that is the correct answer. Next question. The resistance of a wire at a room temperature is 30 degrees Celsius. It is found to be 10% now. To increase the resistance by 10 ohms now. To increase the resistance by 10%, the temperature of the wire must be, okay. Yes, so alpha value is also given. They have given the alpha value as 0.02. Now this is also a very straightforward question. You just have to write the equation at each point. Okay. So the first you have the equation something as the temperature and resistance equation. The first equation you can write as, for 10 ohms you can have R naught into 1 plus alpha into temperature, that particular temperature, okay, like 30. Okay, let's write it directly so that let's not waste a lot of time in explaining this. 30 alpha is equal to 10 ohms, correct? So when you increase 10 ohms by 10%, 10% of 10 is 1. So when you increase, it becomes 11 ohms. So when it becomes 11 ohms, what is the temperature? Once again the same formula. Now this time I don't know the temperature. I'm just writing as T. Okay. Now what you do is, let me just make this clear. Now what you do is, just take a ratio. So when you take a ratio, you will get 10 by 11 is equal to 1 plus 30 alpha divided by 1 plus T alpha. Now what you do is just solve for T. Substitute the value of alpha 0.02. Okay, slightly lengthy calculation because you have very small numbers, multiple cross multiplication and division. So just cross multiply, substitute the value of 0.002 as alpha, and ultimately you will get the temperature as 83 degrees Celsius. ultimately you will get the temperature as 83 degrees Celsius. Once again, if you have any contradiction, if you have any doubt, somewhere you feel that there is a mismatch in the numbers or the calculation, please let me know in the comment section. So the concept is clear, I believe. It's just temperature dependence of two different temperature or two different resistance values. Just take the ratio, cancel out the common term, R naught will get cancelled, and ultimately you have to solve for T, which you will get it as 83 degrees Celsius. Alright, fine. So this once again is a very simple question. It's not a very difficult question, very easy. If you know the formula, you can do it directly. Alright, let's see the next question. In the adjoining figure, this is the figure, two very long parallel wires A and B carry currents of 10 ampere and 20 ampere respectively and are at a distance 20 centimeter apart. Okay. Now the third wire of 15 centimeter length having a current of 10 ampere is placed midway between them. Then how much force will act on C with the direction, net force? Now see here, so you have three wires. So what is the net force on C? So since all of them are in the same direction, there will be attraction on both the sides. So there will be one force in this side and there will be another force on that side. Okay, let me write that in red, that will be better. So there is one force in this side and there is another force in this side. This force is FAC, okay, towards the A, and this is FBC towards B. FAC and FBC. Now what is the general formula for force of attraction between two parallel conductors? F is equal to mu naught I1 I2 into L divided by 2 pi r, the distance, correct. So now FAC, okay, for A and C, mu naught is 4 pi into 10 to the power minus 7, okay, into I1 I2. So current of A and C, current A is 10, C is 10, 100 into length is 15 centimeter, 0.15 whole divided by 2 pi into 10 centimeter, 0.1. Okay, so you can do the calculation, you can find the answer. So this will be approximately 3 into 10 to the power minus 5. Okay, so you can cross check, you can do the calculation, you can cross check. Okay, now the next one is FBC. Now this is towards the left. Okay, because FAC is towards left and FBC is towards the right, the value is given as, once again substitute the same formula, 4 pi 10 to the power minus 7. Now B is 20 ampere, B is 20 ampere and C is 10, so this is 200 into 0.15 divided by 2 pi into same distance 0.1 because it's midway. So this obviously you know this is 100, this is 200, this is the only difference, so it's double. 6 into 10 to the power minus 5, this is Newton towards right. So ultimately the net value will be towards the greater value, that is the net direction will be towards the greater value. So the greater value is BC towards right, smaller values towards left. So the rightward force will dominate and the net is 6 minus 3, 3 into 10 to the power minus 5 towards right. Option B is the correct answer. Ultimately it will move towards right. The net value is 3, 6 minus 3, 3, 10 to the power minus 5 towards right. So option B is the correct answer. Alright, so this once again please mark this question as very important question because force between parallel conductors is one of the favorite question of the examiners. They have repeated it many times, okay, many times they have repeated this. So please be mindful of such question, that is force between parallel conductors, and this is a very important formula that you need to know so that you can use it. So if you know this and you can flow it very correctly, it's a very easy question, but if you find it difficult and you lack practice, then you might find it a little bit difficult, slightly, not a very difficult but slightly difficult towards the medium side. Alright, fine. Let us look at the next question. In a moving coil galvanometer, the deflection of the coil theta is related to electric current by relation. Very simple question, straightforward. You just need to know about two constants, which I think it's kind of the prime quantities in this topic of galvanometer, moving coil galvanometer, that is current sensitivity and galvanometer constant. So galvanometer constant is fixed for a particular galvanometer, okay, that is the characteristic of the galvanometer. So the figure of merit, that is given as current identified or detected per unit deflection, I by theta, okay, I by theta, this is the galvanometer constant. Okay, so I by theta is a constant. Sorry, I by theta is a constant. It's called the galvanometer constant or figure of merit, I by theta. Okay, the amount of current flowing per unit deflection. Now this itself will give you the answer that current is directly proportional to theta. No other variation or possibility. Current is directly proportional to theta in a moving coil galvanometer. Alright, so it's a very simple straightforward question. There is no chance of doubt here as well. Okay. Yes, next question. A beam of electrons is moving with constant velocity in a region having simultaneous perpendicular electric and magnetic field of strength 20 volt per meter and 0.5 Tesla, right angle to each other. The direction of the electrons is. Now this is a very important concept. It's an indicator. Constant velocity, mutually perpendicular magnetic field and electric field, direction of motion, velocity of the electron. This is the constant belonging to velocity selector. Okay, so we will have a constant velocity when electric field and magnetic field are perpendicular to each other, and that constant velocity value is given as the ratio of E by B, that is 20 divided by 0.5 in this case, which is 40 meter per second. The correct answer is option C. Velocity selector is actually a very simple concept. You just have to look for the keywords. So you have electric field and right angles to the direction of the motion, simultaneous perpendicular electric and magnetic field, constant velocity, simultaneously perpendicular or mutually perpendicular electric field and magnetic field, which is again perpendicular to the motion direction. This essentially gives you the velocity selector indicator. It indicates you, it's a velocity selector question. Velocity is E by B and you will get the answer. Very, very simple question. Alright. So please don't miss such kind of questions. And the next question is, at what distance from a long straight wire carrying conductor a current of 12 ampere will the magnetic field be equal to? This once again is an infinitely long conductor, the field at some distance. So you are asking the distance. For an infinitely long conductor at a particular distance r, the magnetic field is given as B is equal to mu naught, it has a current I divided by 2 pi r. So r is very simple, just bring the B down, cross multiply mu naught I by 2 pi B. Substitute all the values. Mu naught is 4 pi into 10 to the power minus 7, right? 4 pi into 10 to the power minus 7 into I value is given as a 12 ampere whole divided by 2 pi into B value is 3 into 10 to the power minus 5. So ultimately the R value you will get it as approximately option A, that is 8 into 10 to the power minus 2. So once again our calculation you can do it yourself, students, and if at all you are finding any contradiction, you are finding any hiccups somewhere here and there that you are not able to proceed beyond a certain level, please let us know in the comment section. So comment section, let me remind you, use it as an efficient way of communicating to us of not only regarding this particular video or anything regarding the channel, any request from your side or any comments from your side. That is the purpose of comment section. Please utilize it efficiently. All right. Yes. So let us look at the next question. The next question is, a coil in the shape of an equilateral triangle, okay, of side 0.02, equilateral triangle 0.02. It is suspended vertically from its vertex, so it is like this, it's hanging, okay, and in a vertical plane, the between the poles of piece of permanent magnetic field is given. So if the current of 0.1 ampere, the current also is given, then what is the couple acting? Basically the torque. What is the couple acting is what is the torque acting over here. Alright, so how do you find this? Is very, very simple. Once again, the formula for the torque acting on a coil is given as, the formula for torque acting on is M cross B, okay, M cross B, or it is MB sine theta, MB sine theta, or you can also write it as I into A into B. Now theta is mostly perpendicular, so you can take it as sine theta as 1 itself, so no worries on that. Okay, now IAB. Now how do you find A of a equilateral triangle? Area of an equilateral triangle, if something is the side distance is A, if it is A, so you can take it as root 3 by 4 into A square. Okay, root 3 by 4 into A square. So your area will automatically, if A is 0.02, your area will automatically become root 3 into 10 to the power minus 5. Okay, sorry, minus 4 meter square. So area is this much, current is given, magnetic field is given. I urge you to substitute everything. Current is 0.1 into root 3 into 10 to the power minus 5 into magnetic field is 5 into 10 to the power minus 2. So ultimately you will get the answer as option A, that is 5 root 3 into 10 to the power minus 7. Okay, minus 5 minus 2, the correct answer is 5 into root 3 into 10 to the power minus 7. Okay, sorry, this is 4. It's not 5, it is 4. So 4 minus 2 minus 6, there is a 0.1, that's what I missed, sorry. So we will have 5 root 3 10 to the power minus 7. Alright, so once again this is a very simple calculation. I don't think there is any clue of any doubt. So you can do it very directly. Yes, all this small basic knowledge, okay, how to find area of a particular shape and all, you must know, otherwise it's going to be difficult. So if you know all these things, if you are very adept and you are practicing very regularly, all of this will be very easy for you. Yes, actually it's a very straightforward question, very simple, very straightforward question. Alright, let's look at the next question. Okay, so the penultimate question, that is the of this particular video. The distance at which the magnetic field on axis as compared to the magnetic field at the center of the coil carrying I and this. Okay, now this is a very important question because this ratio of axis to the center. Okay, so how do you find that? So there is a direct formula. I would like you to please make a note of it. Magnetic field at center, magnetic field at axis with respect to magnetic field at center. Now this ratio is given as r square by x square plus r square whole power 3 by 2. Whole power 3 by 2. Now this is the formula. It's very important formula. Please keep it in mind. R square by x square plus r square. Okay. So now you can substitute, the ratio is given, that is 1 by 8. Bx by b naught is 1 by 8. So you can substitute that. Okay. You can substitute this and then you can find, see, the distance at which the magnetic field. Yeah, so you have to find the x value. Okay, you have to find the x value. So r square divided by x square plus r square whole power 3 by 2. So apply this. So when you apply this, you will get r cube in the numerator. Okay, you will get r cube divided by x square plus r square whole power 3 by 2 1 by 8. So cross multiply and solve it yourself. Okay, that I will give it to you. So just cross multiply and solve it yourself. So ultimately you will get that x square plus r square is basically 4r square. Okay, x square plus r square is basically 4r square. So here and there if you do something, you will get the answer, and then ultimately you will get x is equal to, x square is equal to 3r square and x is equal to root 3r. Alright. So the distance at which the ratio becomes 1/8. Okay, the ratio of axis to the center. Okay, magnetic field to the axis to the center at the ratio is 1 by 8 when that axis distance is root 3 times r. So the correct answer is option D. The correct answer is option D, right? So once again, I really urge you to, lot of steps, yes, I have kind of jumped because you can just try it yourself, all this solving, just cross multiply and try to find the answer. I hope you can really do that. Alright, fine. So now the last question of this particular video. So let's see that. Now this actually, you need to know this formula. If you know this formula, yes, it's a very simple question, but I have noticed that this formula is not discussed much. So please make note of this formula, is very important. Ratio between the axial magnetic field and the central magnetic field for a loop. Okay. last question of this particular part, that's the 30th question that we are going to deal, is very simple question. Magnetic permeability is maximum for, yes, all of us know it is for the ferromagnetic substance. Magnetic permeability mu is maximum for ferromagnetic substance, very big, okay, compared to diamagnetic and paramagnetic. Fine, so that is what you have to know. So it's a very simple question, right? So all the questions have been covered, all the 30 questions. So once again, I request all of you, if at all you have any doubts or you want to have any clarification, please let us know in the comment section. And also don't forget to join the KCET WhatsApp channel for all the updates, anything regarding whether it is the Abhyas mock test series, the question papers, the solutions, or even if it is regarding the new crash course that we are doing. Okay, that is the Lakshya crash course for all of you. So anybody interested, you can get to know all the details in that particular WhatsApp channel, right? Fine. And that's the end of this video. So I hope all of you have liked this video. If you have liked this video, please like the video and subscribe the channel without fail, and let all of you know. Okay, so many people are aspiring to crack KCET and they are trying continuously, so to make their lives better, please share all the videos that we do in our channel to them, ask them to subscribe to our channel. All right, so that we can help you at our maximum, we can go ahead towards your dream of cracking KCET at beautifully and getting into one of the top colleges in Karnataka. Fine, so that's it. Me Karthik signing off. Until the next time we see, bye and